prove or disprove the following statement. If A and B are symmetric matrices, A times B is symmetric if and only if AB is equal to BA. Remind yourself of the definition of symmetric matrix. Matrix A is called symmetric if it is equal to its transpose. Okay, so in this statement, we have left-hand side and we have right-hand side. It says A times B is symmetric. Then we want to show that AB is equal to BA. Also, you can say that AB is equal to BA, then you can show that AB is symmetric. Let us try to prove this statement. Using direct definition. And properties. So on the left-hand side, what do we have? On the left-hand side of if and only if, we have AB to be symmetric. So what's the meaning of that? Since on the left-hand side, we have A times B is symmetric, it means that A times B transpose is equal to A times B. Also recall the properties of the transpose. Recall that AB transpose is equal to the transpose of B times the transpose of A. So we're going to use this property as well. On the left-hand side, you end up with B transpose times A transpose. And on the right-hand side, it is equal to A times B. But at the same time, we know that A and B are symmetric matrices. So your left-hand side becomes B times A, and on the right-hand side, you have A times B. A is symmetric, B is symmetric. So basically, A times B is equal to B times A using the definition and properties of being symmetric. So A transpose is equal to A and B transpose is equal to B. So that's how you can replace these B transpose by B and A transpose by A. So you just show that BA is equal to AB and you just prove this statement on the right-hand side because your right-hand side says AB must be equals to BA. You could also start by taking the quantity on the right-hand side, this statement on the right-hand side, and show that AB is symmetric. We can also take the right-hand side and prove left-hand side. But the right-hand side says, well, AB is equal to BA. And we want to show that A times B is symmetric. The right-hand side state that AB is equal to BA. We want to show left-hand side. we want to show that AB is symmetric. So again, from right-hand side of if and only if, you have AB equals to BA. So keep this property. At the same time, the transpose of AB using the properties of the transpose is equal to B transpose times A transpose. At the same time, since B is symmetric, so the transpose of B is equal to B itself. So this guy is equal to B. And with the same argument, A is symmetric. It means that the transpose of A is equal to A. So it is multiplied by A. But because of the properties on the right-hand side that says AB is equal to BA, you can write this guy as A times B. So what we just showed that the transpose of AB is nothing but AB. What's the meaning of that? It means that, and it means that the product between AB is symmetric. So let us recap what we did. We have a statement. If A and B are symmetric matrices, AB, the multiplication between them, is symmetric if and only if AB is equal to BA. We started by taking the left-hand side and prove right-hand side. You could also take right-hand side and prove left-hand side. We remind ourselves of the definition of symmetric matrix. On the left-hand side of if and only if, we have AB as a symmetric matrix. It means that the transpose of AB is equal to AB. But using the properties of the transpose of AB is the transpose of B times the transpose of A. But from the statement, we know that A and B are both symmetric matrices. It means that the transpose of A is equal to A and the transpose of B is equal to B. So BA is equal to AB on the right-hand side. Well, this is basically the right-hand side quantity that you're trying to prove. We could also start by the right-hand side of if and only if and prove the statement on the left-hand side of the if and only if. The right-hand side says AB is equal to BA. It means that the multiplication is commutative. We want to show that A times B is symmetric. The right-hand side says AB is equal to BA. Okay, keep that. What is the transpose of AB? Based on the properties of the transpose, it is the transpose of B times the transpose of A. But at the same time, since B is symmetric, the transpose of B is equal to B. And since A is symmetric, the transpose of A is equal to A. Just substitute them. So here you get B times A, but because of the right-hand side properties, you can write it as A times B. Well, the transpose of AB is equal to AB itself. What's the meaning of that? It means that A times B is a symmetric matrix, and we are done.